Dear students, in our previous class we have started our chapter, 11th chapter, that is by name pointers, and we have discussed few things about pointers. But in our today's class we are going to discuss few more things regarding pointer. As in our previous class I have explained you about the address of operators. Now we are going to discuss about that address of operator, how it works and what actually the address of means. Come, we shall see the address of operator. Look, address of operator, it looks like this. Okay, and this we call in English as and or and in computer this will be called as ampersand, as I have explained in previous class that this is ampersand. Okay, and this ampersand is used as address of operators. So come, we shall see how this address of operator works. Is a unary operator that returns the memory address of its operand. See, this operator is called as an unary operator. Okay, in types of operators we have already discussed. That is unary operators, binary operator, then ternary operators, like that we have discussed. Among those operators, this is the unary operator. Okay, that returns means gives the address of, that means memory address of its operand. This operator is used with, if we use this operator with some operand, then this operator will give the address of that operand. Okay, later I will give you the example as I have given in our previous class. I will going to give you the same example in today's class also, so that you can understand it clearly. Okay, and now write down and take for example, if VAR, okay, is an operand. Okay, it is an operand, or take it as, okay, don't take it as operand, take it as integer variable. Okay, if I explain you like this, you will understand clearly. Integer variable. Okay, it means VAR integer variable means int var. Okay, this is a variable of type integer. Okay, then okay, this address of VAR is its address. Okay, this means if we use address of operator with VAR, this will store the address of VAR. Address of VAR means, think these are the memory locations. Here 1, 2, 3, 4, 5. So we take it as 0, 1, 2, 3, 4. 0, 1, 2, 3 and 4. Okay, if VAR is stored here, okay, the variable VAR is stored here. If we use the address of operator with VAR, then this will store the address. Okay, you know that this is the address and this is the location. Okay, address and location. If we use address of var, then this will store the address of the variable var. So this is the use of the address of operator. Next come we shall see how it works. This operator has the same precedence it has the same precedence and right to left associativity. Okay, right to left associativity. Later I will explain this. As the other unary operators. Okay, look here. Unary operators, they operate from right to left. It means this is a unary operator, the address of. Okay, we will take with integer variable value. So this operator works in its right side. Okay, this is called right to left associativity. Okay, has the same precedence as other unary operators. So this is how a address of operator will work. And next point, you should read how you should read this. Okay, you should read this operator. Okay, operator as the address of you should read like this, as the address of, which means okay, take the same example. This ampersand var can be read as the address of var. Like this we have to read this operator. So I think you have understood how this address of operator will work and in what way we need to read this operator as. Okay, if you use the operator with any variable, then it can be read as the address of. Now I will going to give you the same example which I have given in my previous class. That is example, take integer type, that is num, whose value is 25. And now we need to assign this value to a pointer, or we need to store the address of this num. Okay, then we need to write it as int, okay, star etr, take a pointer. Okay, after that address of ptr is equal to, okay, after this we have to write it as ptr, okay, is equal to address of num. Okay, what is the address of num here? Address of num is the num is stored in address 25. Okay, take a pointer variable and assign the value, the address of num to that pointer variable. Like this we can use this address of operator. And we have discussed now about the address of operators. And now the next operator is pointer operator. Pointer operator or indirection operator. Pointer operator or indirection operator. So what is this pointer operator or indirection operator? It is the asterisk operator. Okay, this operator can be called as a pointer operator or the indirection operator. Come we shall see what is the working of this pointer operator. So far we are using this pointer operator with every pointer wherever it comes in a program. And now we need to understand about this pointer operator, how this can be used and for what this pointer operator has to be used. Come we shall discuss now. This is the second operator. Okay, the second operator is the pointer operator or indirection operator. The pointer operator. Okay, and this can be called as indirection operator. Indirection operator. Okay. Indirection operator. And how it works? This is the complement of the address of operator. It works as complement. If address of operator stores the address of a variable, okay, the address of an operand, but the pointer operator stores the location of the operand. Okay, whereas the address of operator stores the address of operand. In the same way, the pointer operator stores the location of an operand. Come we shall see. And it is the complement of this can be written as not just address of the address of complement of the address of operator. The address of operator. Which is the address of operator? This. The address of operator. And how it works? Complement means this stores the address of a variable, but this stores the location of a variable. It is a unary operator. It is a unary operator that returns the what it returns, whereas address of operator returns the memory address of the operand. But what the pointer operator or indirection operator returns? It returns the value of the variable located. The value of the variable. The value of the variable located means the place where exactly the variable is located. It will return the value of that variable location. Okay, the location of the variable. At the address specified by its operand. Okay, the address specified means location of the variable it will give. Okay, now take the same example. Int, okay, num equals 25. Okay, then int star PTR. So this is the pointer operator. So I will write comment for this, that is pointer operator. Pointer operator, and this pointer operator can be called as indirection operators. Indirection operator, that is star. Right? Yes. Pointer operator or the indirection operator. Then this pointer operator, it stores what? The address of num. Whereas it directly stores the location of num, but address of operator stores the address of num. So this is what regarding the indirection operator or the pointer operator. Now I am going to write a programming example, so that you can understand the working of the address of operators and also the working of indirection operator, that is the pointer operator. Now write down the programming example for the working of these two operators, that is the address of operator and the pointer or indirection operator. Write down the programming example. As usual, we will make it two parts. Hash include, okay, IO screen dot, okay, dot net. Then after this, hash include IO nanny dot net. And after that, okay, here we are not taking any class. Okay, just we are writing direct program. Void, then main. After this, starting of a main function. Then take three variables. Int var is 1. Then int star ptr is the 1. And take one more as int var. Okay, after this, now start its working. Okay, here we have taken three variables. One is variable, next one is ptr, next one is var. Now we need to use two operators, that is the indirection or the pointer operator, and one is the address of operator. Here already we have used indirection operator. Now we have to use the address of operator. So take some value for var. var equals, take some value. Okay, like this we have to take some value. After that, assign this value to ptr, that is ptr, okay, equals ampersand var. Okay, assigning this address to pointer ptr. Then value, we have left with value, take this value as val, okay, equals star ptr. So here, okay, value is taken as the address of ptr. Like this we have to do. Then after this, finally write the output statements. I will write here, take this line a bit closer. Okay, I will write the output statements now. Okay, C out. Okay, C is the small one, don't write it as capital. Value of var equals. Okay, then we have to take it as variable var. Okay, then next line, end of line. Okay, if we give end, the control moves to next line. Then here C out. Okay, then after that, value of ptr. Value of ptr. Okay, this equals. Then take it as ptr. After that, give end of line. Control moves to next line. Then after that, C out. Then finally value of VAN, value of VAN, which is equal to, then give it as variable VAN. After that, end of line. Okay, then get CH, then close the program. Let's see here, indirection and pointer operator is used and the address of operator is used. And now write the output of this program. Value of VAR, which is equal to, we have already given the value. What is the value? That is 3000. It will print the same value here. Okay, then value of PTR. Value of PTR means it will print address of VAR. Okay, so the address where this VAR is located, 0 into, it will print some different address, that is BFF 64494. It means in this address this VAR is located. Then finally value of VAN, which is equal to 3000. Like this program will give you the output. So hope you have understood the working of the address of operator and the indirection or the pointer operators. Okay, so far we have discussed about %, that is the address of operator, and the pointer or the indirection operator. Now you have already understood that pointer is a address. Okay, you can, and it is a numeric value. Pointer is a address and it is a numeric value. So though it is a numeric value, you can perform arithmetic operations on pointers, just like how you perform the arithmetic operations on other operators. The same way you can perform the arithmetic operations on the pointers. So now we are going to discuss about the arithmetic operations on pointers, which can be written as pointer arithmetic. Pointer arithmetic. Pointer arithmetic. So what are the type of operations we can perform on pointers? Come, we shall see. That is, there are 4 arithmetic operations. There are 4 arithmetic operations. There are 4 arithmetic operations. How many operations we can perform on pointers? There are 4 arithmetic operations that can be performed. On pointers. Come, we shall see which are these 4 arithmetic operations. So the first one is the increment operation. Okay, and the next one is the decrement operation. Okay, after that unary addition. Then the last one is, that is dot operator. Dot operator. So these are the 4 arithmetic operations we can perform on pointers. Okay, come, we shall see with the help of these 4 operators. Okay, and write down this as, these are the 4 operators. These are the 4 operators can be used on pointers. Yes, can be used on pointers. Okay, for arithmetic operations performed on pointers, that is increment, decrement, unary, addition and dot operation. Here these are the four operators that can be used on pointers. By using these operators, what are the things we can able to do? Okay, by using these operators, what are the things we can able to do? Now we shall discuss. Following operations can be performed on pointers. Following operations can be performed on pointers. Which are these operations here? First one is we can add an integer value. We can add an integer value to a pointer. Okay, with the help of these operations, we can add an integer value. Integer means numeric value 0 to 9 among them without decimal point. Okay, the integer values are the numbers or the series of numbers or the sequence of numbers without a decimal point. Okay, we can add that type of integer value to a pointer. Okay, the next thing is we can, as we add, okay, the same way we can subtract. We can subtract an integer value from a pointer. Okay, as we can able to add the integer value, okay, the same way we can able to subtract an integer value from the pointer. These are the things we can do, and few more things are there. We shall see here. We can compare two pointers. We can compare, okay, two pointers. We can compare two pointers. When we can compare them, we shall see. If they point the elements of the same array. Okay, look here, we can compare two pointers. When we can compare, if they point the elements of the same array. Take array as an example. This is an array. It has A, B, C, D. Take two pointers. Okay, those pointers are pointing. One is B and another one is pointing to D. We can compare these two pointers because these two are the elements of same array. Okay, but not the elements of different arrays. These two are the points of same array. In this situation, we can compare these two pointers. So this is the one thing possible by using the four operators of the pointers, arithmetic operators. And the last point is, last 2 points are there. We can subtract. One pointer from another pointer. The same here. If both points to the same array, Okay, as we can do comparison if they point to the same array. The same way here, subtract one pointer from another pointer if both point to the same array. Okay, in this situation we can be able to subtract. And the last one is we can assign, okay, one pointer to another pointer. We can assign one pointer to another pointer, okay, if they are of the same type. Pointer provided both are of same type. Okay, we can assign one pointer to another pointer. It means think, okay, I'll write here star IPTR is one pointer. Okay, and the next one is star FPTR. Okay, if both are of the same type, then we can assign the value of 1 to value of 2, value of IPTR and FPTR. The value of FPTR is assigned to the value of IPTR. Okay, as we have discussed, if both elements are from the same array, then we can add. If both elements are of the same array, then we can do subtraction. And if both are of same type, it means same array, then we can assign the value of one pointer to another pointer. So these are the things we can able to perform with the help of these operators. And come we shall see what are the things we cannot do with the help of those operators. So now, what are the operations we cannot do on pointers? Following operations cannot be performed on pointers. What are the things we cannot be able to do? The first, addition of pointers. When we cannot able to do addition of pointers, if they are of different type. Addition of two pointers. Addition of two pointers. Okay, if they are only the addition of two pointers. Write down like this. Addition of two pointers. Then after that, next one is subtraction of one pointer. You know, addition of two pointers we cannot able to perform. Okay, because in operations, performing operations also, there is no addition, only comparison is there. After that, subtraction is there, no addition is there. So we cannot able to perform addition of two pointers. Then subtraction of one pointer from another pointer. Okay, at what time? If they are not from the same array. If from the same array, if the elements are of same type, we can perform subtraction. But if the elements are from different type, not from the same array, at that time we cannot able to perform these operations. When they do not when they do not point to the same array. When they do not point to the same array. Okay? These things cannot be done. Subtraction of one pointer from another pointer when they do not point to the same array. If the pointers are from different arrays, then we cannot able to do subtraction. And the next thing is multiplication of two pointers. We cannot perform multiplication of two pointers here. Okay, multiplication is not possible. And then the last one is division of two pointers. Division of two pointers. These are all the things cannot be performed. They are very easy. Addition cannot be performed. Addition of two pointers, multiplication of two pointers, division of two pointers cannot be performed. And subtraction of one pointer from another pointer will not be possible when those two pointers are from the different array. Okay, hope you have understood these things. Now take some examples how the operators can able to perform the operation. Okay, take some examples. Among that first point I will take. First point will be taken as, suppose if p is an integer. Suppose if p is an integer. Suppose if p is an integer, okay, then p plus plus, okay, use of increment operator. P plus plus is incremented by p plus plus will increment p by 2 bytes. Okay, later I will explain, then you will come to understand. By 2 bytes. Each time a pointer is incremented by 1. Okay, each time a pointer is incremented by 1. It points to the memory location. It points to the memory location of the next element of its base type. Now listen students, if we use p plus plus operator with p, okay, as you already know that if you do for loop, okay, I equals 0, okay, I less than or equal to n, then I plus plus. So what is this plus plus? It will increment by 2 bytes. If we use p, okay, take p as an integer, then if we use p plus plus with p operator, then it will increment p by 2. If the value of p is 0, at that time if we use p plus plus, then the value of p will become 1. and in next repetition the value of p will become 2. Like this, increment by 2 bytes. Okay, increment by 2 bytes. Each time a pointer is incremented by 1. Each time, in each run, in each what we say compilation, in every compiling time, it is incremented by 1. Okay, pointer is incremented by 1. Okay, and what it will do, it points to the memory location of the next of its base type. Okay, if it present in the first location, at next it will points to the next memory location. Like this, the plus operator will operate. Come, we shall see the next point, how it works. Here, suppose if p is a char variable or char pointer, p is a char pointer. Okay, when it is integer type, incremented by 2. When it is a pointer type, sorry, it is a char type, then p plus will increment by 1 byte. Will increment by 1 byte. Okay, if it is of integer type, then this will be incremented by 2 bytes. Okay, or if a pointer is character type, the usage of plus with p will increment by just 1 byte. So these are some of the examples you need to know. Come to the next point. Now we are going to work with p minus. For p minus, okay, each time a pointer is decremented by 1. Okay, here pointer will increment each time by 1. Okay, but if we use minus with p, then it will be decremented by 1. Okay, decremented by 1, and it points to the memory location of the previous element of the base type. This means if two elements are there, one element, if it get decremented by 1, then it will point to its previous element when we use minus with p operators. Okay, hope you have understood this. So here the last point is, if we add p with p, okay, then it will give here comparison is done. P is assigned to p, then sometime it will give integer value. It will add integer value. Okay, and in some time it will minus the integer value. Like this, the operators can be operated along with the pointer. Dear students, if you have any doubts, just keep these things in your mind. How the operators will work. Just keep in your mind. That's it. Write down somewhere and keep in your mind. Then only you can understand the next concept. Okay. If you have any doubts regarding today's class, you can ask me personally.